Okay, first thing I want to do is go to our notes from trapezoids from last class. Okay, and talk about angle measures. So I know this was like very rushed because we were at the end. So on the second page here, problem number 2, how do you know that, let's see, first of all, how do you know that the segment in the center of the picture there is a mid-segment? How do you know that this is a mid-segment?
Because of the congruent sides and then the parallel sides.
What do you mean by congruent sides, Jake?
The sides that WR and RZ are congruent, and then XT and TY are congruent. And the two. Huh?
I just didn't want to cut you off.
No, you're good. I was going to say anything.
Okay, so R is a midpoint, T is a midpoint, and then remember a mid-segment, you know, has to be parallel to the two bases. So tell me what the measure of angle Y is and why. Ryan Haggerty, can you tell me what the measure of angle Y should be?
Would it be 50?
Because what?
It has to be supplementary.
It has to be what?
Supplementary.
Yeah. So why do these two angles have to be supplementary?
Isn't it because the whole shape has to add up to 360? So like RZYT, like that whole shape would have to be 360. And if the other sides are one, like together would be 180. And so you add it together, 360.
Okay. Yes, that is true. Over here, oops, sorry. Over here is going to have to
Isn't
be.
it just consecutive interior?
Yes. Yes. So Kara, yeah, the other side has to be 180 and this side has to be 180 to make up the rest of the 360. But you know it has to be 180 because they're consecutive interior in the parallel lines. Okay, so parallel lines make consecutive interior angle supplementary. So remember that when you draw in the mid-segment, you're actually creating in the big trapezoid, which you know it's trapezoid because it has two parallel sides and two non-parallel sides. You're actually creating a small trapezoid here because the mid-segment's parallel to this base. And you also have a little trapezoid here. So when you draw in a mid-segment and trapezoid, you actually have 3 trapezoids there. Okay, and then tell me how we would know that this angle measure is 50 degrees. So there's 2 reasons, at least. Tell me one reason why that has to be 50.
Corresponding.
Okay, the lines are parallel and they're corresponding angles. So these 2 have to be congruent. Okay, and then another reason that it has to be 50 is what?
The lines are congruent.
I'm not sure that that necessarily means that those would have to be congruent. How are these 2 angles related? This one and this one. Austin, how are those 2 angles related?
Are they supplementary?
Yes, but they're what? If they're adjacent and supplementary, they're what? It's 2 words. We talked about like complementary and supplementary vertical angles and like what is it when you have 2 angles that are adjacent and supplementary? Like this is 20 and that's what.
Oh, a linear pair?
They're a linear pair. So You would know there's two reasons how you know that that has to be 50, the corresponding, and then also just the fact that it's a linear pair with 130. You can do use the corresponding angles also to jump up to here and get that this one has to be 130 since it's got to be congruent to the 130 down there. All right. We can do something similar also on the other side. We talked about how that these would all have to be 90 because of the fact that you've got to add up to 180 here and here and here, and you've got corresponding angles, consecutive interior and all that. Okay, so that side's a little easier. But remember that you don't have to have congruent base angles unless it's an isosceles trapezoid. So this has a 90, a 90, a 130, and a 50. So it's not isosceles. It's not always the case that the base angle pairs have to be the same. Okay, always, sometimes, or never. The trapezoid is always, sometimes, or never a parallelogram. I'm going to call on you guys. Kendall. Trapezoid is always, sometimes, never a parallelogram.
Is it sometimes?
So let's make a little.
Actually, wait, no, never.
Okay.
Never.
Why? You're right.
Because yeah. Because like it's separate branch on that diagram.
Exactly. So remember that our tree diagram, trapezoids only have one pair of opposite parallel sides. They have one and only one. So that means they cannot be parallelograms. And remember, underneath trapezoids, you'd have isosceles trapezoids here. Where do kites go in the family tree? Grace, where are kites in this quadrilateral family tree?
Aren't they like by themselves?
They're by themselves, yes. Kites don't have any parallel sides. So you kind of got like one pair, two pairs parallel, one pair parallel, no parallels. Okay, so a trapezoid is never a parallelogram because they're completely different quadrilaterals. They're in different branches of the family tree. The bases of a trapezoid, always, sometimes, or never parallel. Gabe, always, sometimes, or never.
Always.
Okay. How do you identify the bases in a trapezoid? Like if I draw a trapezoid like this. If I draw a trapezoid like this, which ones are the bases?
The top and bottom one, like the top and bottom, the ones with arrows, like in the middle.
Like, what do you call the other ones?
Um, mm,
Somebody help him out. This is a base.
Is it called the legs?
Those are legs. Yes. Who was that?
Michael?
Okay, so the bases will always be parallel. When will the legs be parallel? Always, sometimes, or never? Never, right? That's what makes them the legs. Okay, the base angles of an isosceles trapezoid, are they always, sometimes, or never congruent? The base angles of an isosceles trapezoid, always, sometimes, or never congruent.
Always.
Was that Lily?
Yeah.
Always. That's a property by isosceles trapezoids, right? That forces the base angles to be congruent. The legs of a trapezoid are always, sometimes, or never congruent. Blair, what's that one? The legs of a trapezoid are always, sometimes, or never congruent.
Sometimes,
Okay. Why is it not always?
because in that little picture you drew, or like sometimes in the trapezoid, the legs don't always have to be congruent.
If they are congruent, then it's what kind of trapezoid?
Isosceles trapezoid, or I don't know.
In general, trapezoids don't have to have congruent legs, but if it's isosceles, that means it has congruent legs. That's a sometimes. Okay, consecutive angles of a trapezoid are always, sometimes, or never supplementary. Consecutive angles of a trapezoid are always, sometimes, or never supplementary. Let me put some numbers here in this little trapezoid.
Wouldn't it be sometimes?
Okay, why?
Because like some of the angles will be like they both the sides have to equal 180, but like the two bottom angles, like they're like sometimes they're not like supplementary.
Give me numbers I could put. I want to put some angle measures in this little trapezoid. Tell me numbers there.
You could put like 50 and then like 130 for angle A.
Okay, if that one's 50, does that other one, does angle A have to be 130, or did you just make that up?
I just made that up.
No, you didn't.
Or yeah, it has to be supplementary.
Yeah, so
Yeah.
the consecutive interior, so those two have to be supplementary. Okay, Izzy, tell me two numbers I could put over here. If this is not isosceles, give me two numbers I could use over there.
You could use 180.
Okay, so let's say that's 100 degrees. This one's 80 degrees. Okay, so this is a generic trapezoid. This is not an isosceles trapezoid. So are all of the consecutive angles supplementary? Well, no. You're going to have the two there supplementary, and you're going to have the two here supplementary. And that's because you have parallel lines here. What would happen if angle L and angle M were also supplementary? Is that possible?
No.
Is it possible to make the one over here 130? I would change that one too. Is that possible in a trapezoid?
No.
Because why?
I don't know, it just doesn't look like it could be 130 like the angle.
If those two were supplementary, what would that do to those other lines? This doesn't have to be Geron. This can be anybody. What would happen to the other sides if angle L and angle M were supplementary?
Would they be parallel?
End up making them parallel. Good, Lily. Okay, so in a trapezoid, you will never, ever, ever have all of the consecutive angles supplementary. Remember, that was kind of like a way to prove parallelograms, as if you had supplementary angles all the way around consecutive angles all the way around that were supplementary, that made it a parallelogram. So in a trapezoid, yes, that will be sometimes, because consecutive angles can't all be supplementary. I hear the sirens. They're not always going to be supplementary, but you will have two pairs, and that's whether it's a isosceles or not. Trapezoid. Diagonals of a trapezoid, always sometimes are never congruent. In general, are the diagonals of a trapezoid congruent? So if I draw in this diagonal and that diagonal, are they going to be congruent?
No.
In that trapezoid, no, they're not congruent. Can they sometimes be congruent?
Yeah.
So that's only true in isosceles trapezoids. That's a sometimes, because it's a property for isosceles trapezoids, but not true about trapezoids in general. Okay. And then this one is actually a repeat. That's the same as like the fourth one down. All right, let's talk about homework. Okay, so we've got.
Wait, can you go back to the notes real quick?
What did you need to see, Blair?
Let me just take a screenshot real quick. Okay, thank you.
Things on my homework, like part of it isn't showing up. So I don't know if it like, when I turned it in, if it like deleted it or something, but I did those problems, but I don't know what happened to it.
Okay, I'll look at it and we can talk later. All right, take a look at those. Okay, do you have any questions about the first four? Okay, now again, in a trapezoid, this one happens to be isosceles, but in every trapezoid, wherever your parallel the bases are, you'll always have a pair of supplementary on that side and a pair of supplementary on this side. Because this is an isosceles trapezoid, that means the base angles are also congruent. So these two have to be the same and those two have to be the same. In general, you just know that the two sides have to add to, like each side has to add to 180, but it's a little bit more specific in isosceles trapezoid. Okay, for the mid segment, remember that the mid segment is the average of the two bases, so you add the bases and divide by 2. Okay, you add the bases and divide by 2. So if you're looking at a problem like this one, you can kind of just look at that and say, all right, that difference is 6, so I'm going to add 6 to get the length of DG. Those are like really simple. You don't have to actually write an equation for that. But here you need to make sure you know to calculate by adding and dividing by 2, so finding the average there. And then you need to be able to do algebra on this kind because they didn't give you like either of these lengths, so you have to actually do the calculation. At the end, after you have an answer, it's a good idea to go ahead and just like, you know, kind of check it and make sure it works out. I think that's left over from something else. Questions on the first top 2/3 of trapezoids? Okay, here's the bottom ones there. I think I should have, it looks like it wasn't marked. I should have stated that those were trapezoids or else had the drawings on the markings on the drawings. I know I copied and pasted those from somewhere else and you probably said in the directions that they were trapezoids. You really should not assume by how it looks. So I really should be more specific than that. Okay, any questions on the first page? All right, how about kites? So for kite problems, when there's no diagonal already, like if there's not 1 or 2 diagonals already drawn in, sometimes you don't even want to put them in. So for this problem, I think the easiest thing to do is just to use the whole kite has to add a 360 and you know that those angles are congruent. So just make an equation where they all add to 360, right? You're basically subtracting from 360 and dividing by 2. If you want to put in one diagonal will cut that into 2 congruent triangles. And if you want to use 22 and 40 and x equals 180, you can do that. But definitely don't draw in 2 diagonals. Okay, the long diagonal creating the 2 like big triangles that are congruent can be helpful, but you really don't need to do that on the first two problems. Questions on the first four?
Can you do the first problem?
I'm just adding up to 360. So I'm using 44 and 80. And these are the two we don't know, but we know that they're congruent. So again, the line of symmetry would be the long diagonal. So when you fold it over, this one and this one are congruent. So I'm just using all the angles out of 360. And again, you could draw in a diagonal here and do half of 44 is 22, and then X, and then half of 80 is 40, and add that up to the triangle. This triangle at the top adds up to 180. But I think it's actually easier to just use the kite as its own quadrilateral and just add up all the angles to 360. It usually complicates things. If there's no diagonal drawn in, it usually complicates things if you put in both diagonals. Putting in one of them might be, okay, or might be helpful, but if you put both diagonals in there, it usually just complicates it and makes it like much more confusing than it needs to be. Okay, here's, I told you to use the Pythagorean theorem. What kind of triangles can you use the Pythagorean theorem for? What kind of triangles?
Right
Right
triangles.
Right triangles. So you have to know two of the sides. Okay, remember it goes leg squared plus leg squared equals hypotenuse squared. So if you know the hypotenuse, then that's where the number will go, and the variable will go somewhere on the leg side. Okay, on these, sorry, on these we didn't have the hypotenuse length. So on all of these, it's going to be number squared plus number squared equals the variable squared, because the variable's the side we're looking for here. Okay, I'll leave that there and I won't move it so you can look at that, take a screenshot if you need to. Make sure you know how to break down those radicals. Some of us had a little trouble with that on the quiz. So remember, if there's a perfect square that comes out of it, like 32, for example, is 16 times 2. Since 16 is a perfect square, you can just take the square root of 16 and carry along the root 2. But you can also do a factor tree by doing 32 is 2 and 16 and 2 and 8 and 2 and 4 and 2 and 2, and then take pairs. So there's a pair, it's a 2. There's a pair, it's a 2, gets multiplied. And then that one is left over, so it's underneath the radical, so that's 4 root 2. Okay, I think it's easier if you do the perfect square method, so you don't lose any of those little primes. But if you can't find a perfect square that goes into the number, and you want to make sure you get the biggest perfect square. But if you can't find a perfect square that goes into the number, then, just do the factor tree. But like with square root of 80 here, with square root of 80, if you take out a 4, if you do 4 and 20, square root of 20 breaks down again. So although square root of 4 would be it is a perfect square. Since there's 20 left over, it would have to be broken down again. So you want to make sure you get the largest perfect square, or else look for doing multiple steps. Okay, if I wanted the perimeter of, let's say, the first kite, if I wanted you to tell me the perimeter, do you know how to add 4 root 2 and 4 root 2 and 4 root 5 and 4 root 5? Do you know how to add that? I'd like to talk to somebody who has not answered a question today. So that would be, I think, Sarah, Derbla, Sadie, Rylan, and Diamond. Does any of you know how to add those together? I'll give you a hint. You can put those together and you can put these together, but you can't put all 4 of them together. Derbla, do you know how to add 4 root 2 and 4 root 2?
Not really, but I can try. Would it be 8 root 4 or 4 root 4?
So if you had 4x and 4x, what do you get?
8x.
So you don't change the x, right? You just collect all those together. So you have 4 root 2s and another 1, 2, 3, 4 root 2s. So you're just counting up how many root 2s do you have. So it should be what root 2?
8 root 2.
2. The radical part does not change.
Okay.
And then Sadie, tell me what 4 root 5 and 4 root 5 adds to.
8 root 5.
5. And then again, because the radicals are different, you cannot put them together. That'd be like if you had 8x and 8y, how you just leave it 8x plus 8y. So I think there is a question on the review that has a problem like that where I ask you for perimeter of the kite. The radicals, you can only add like radicals together, and it only changes the number in the front. So again, think of these kind of like variables, even though they're not variables, they sort of act like variables. And so again, you can't combine a square root of 2 with a square root of 5 term. Okay, any other questions on homework? Anything you want me to go back to?
Sorry, Kate.
Blair?
Never mind. Thank you.
I want to go back to the problems on ClassKick and work through the, there were 4 problems on that practice that we didn't do. Some of you don't know the properties well enough to be able to get through the different shapes quickly and accurately. Okay, so looking at your quiz, the problems like on the first page, if I remember correctly. Yeah, so the problems where, and it looked like this. I thought I pulled it in already. Place. So, yeah, I didn't. We're in chapter 7 in honors, and my brain keeps going to the wrong place. Okay, now it just disappeared. There we go. On these kind of problems right here, you need to be able to work those out quickly without having to think a lot about them. Okay, so some of us don't know, like especially parallelogram, it seemed like we were kind of rough on that. Remember that in a parallelogram, the consecutive angles have to be supplementary. So if that's 95, that makes this one 85. These are both 40 because they're alternate interior, and that's how you can find this other angle measure. In a parallelogram, the diagonals don't bisect the angles. So some of us were saying that those were both 40. That's not true. And if you throw off one of the angles, it's going to throw off a bunch of other angles. Okay. All right. I want you to go log into ClassKick and find the practice problem 6.4. Those 4 problems right there, we did not have time to do. And I feel like you need more practice on that. So I want you to take a couple of minutes and look at, let's start with, yeah, I think that's fine. Let's go ahead and try 18, 19, and 20. And I'm going to make up another problem for parallelogram, kite, trapezoid, that kind of stuff. All right. And you should be drawing on the diagram. when you're trying to find angle measures, you want to have pictures with like angles drawn in. The good thing about quadrilaterals is everything is so visual. Okay, so what is important about the in a rectangle? What is important that is helpful to make sure you know how to find the angle measures? There's a few. What's one thing that's true? Rectangles.
Each like angle, like A, C, and D are all 90 degrees.
So first of all, if it's a rectangle or a square, right away, you need to make sure you remember that makes those have to be 90. Oh, I forgot to write the angles over here. They're the same though. Okay, how do we know that these angles here have to be the same? How do we know the 66s are the same? Jake's not allowed to talk. How do we know 66s are the same and the 24s are the same?
Because the diagonals form isosceles triangles.
The diagonals are congruent to each other, which means not only do they bisect, but they also make isosceles triangles. Okay, so remember when you're looking at a rectangle, you want to see an isosceles triangle there, and it should match exactly with the isosceles triangle over here. Okay, and then you want to see an isosceles triangle here, and it should match exactly with the isosceles triangle that's like across from it. So things should, like everything should make sense. This is a parallelogram, right? So that means that you should have like alternate interior angles that are congruent. You should have consecutive angles being supplementary. So like all the way around, those on a rectangle are all 90, but that should still make sense. Linear pairs have to add to 180. Vertical angles should be congruent. So, you know, everything needs to make sense when you think you have all the angles there. So remember, these are alternate interior. So that 24 goes down on to the triangle down below it. Okay, for a rhombus. So rhombuses have perpendicular diagonals. When you see a rhombus, the very first thing you should do is draw in those right angles. Okay, what other properties can you tell me about rhombuses that are helpful to figure out the angles? Austin, what else do you know about the a rhombus that helps you find the angle measures?
Two of the side, like the opposite sides are congruent.
That doesn't help you with angles though. All of the
Oh, right.
right.
The consecutive angles are supplementary.
Okay, that is helpful to remember because it's a parallel, right? So this one and that one have to add up to 180. So sometimes that's a helpful way to start. How did I know that that one was 36? So the big angles do have
Because it's an angle bisector.
angle bisector. So when you start with a rhombus, the first thing you should do is draw in the right angles. Then you want to remember that the angles here are the same and they'll be the same as the ones up across from it. Because again, the big angles have to be the same because it's a parallelogram. And then after that, I honestly would just look at the little right triangles, right? You have a right triangle here. How many triangles are there that are congruent to that right triangle? How many other right triangles are congruent to that triangle?
Three other ones.
Three other ones, right? So when you see a rhombus, just look for that right triangle and it just keeps getting duplicated, right? If you fold rhombuses along both diagonals, you'll see that everything should match up. So with a rhombuses should be easy because you always have a right triangle and you just need to look at the angles that are in the right triangle that have to add to 90. Squares are the easiest because every angle in a square is a 45 or a 90. Okay, so you want to make sure that on squares you always have 45s and 90s. And then some of you didn't get to this rectangle, but those are the numbers that should have worked out for that rectangle. Okay, let's talk about a generic parallelogram. If I draw a parallelogram and I draw in the diagonals, If I told you, I'll try to make the numbers kind of easy. If I told you this is 30 degrees, and I told you that the angle measure over here is, let's say 100 degrees. Sarah, tell me an angle measure I could figure out. I'm going to call this A, C, D, E.
B would be 100
Okay,
degrees.
angle ABC, right, would be 100. Okay, Diamond, tell me an angle measure you could figure out.
You can figure out A because aren't they supposed to be supplementary?
So that would make this angle measure how much?
80. So then you can figure out C too.
Okay, so this has to be 80, and that means this angle is also 80. Rylan Mitchell, tell me what another angle you could find.
Um, it's supposed to be E, but I don't know what it would be.
Okay, what can you tell me down here?
That angle is 80.
Okay, but you can tell me this angle, right?
That angle is 50.
Angle's 50. Now here's the problem. Some of us on a generic parallelogram, we're using that that's an angle bisector. It's not, okay? What you do need to use is the supplementary consecutive angles, and then you can use the little ones add up to that angle. Could you tell me any other angle measures? This can be for anybody.
Oh,
Any other angles?
Angle AEB is 30 degrees.
This angle?
No, angle EAB.
EAB. Okay. EAB is 30. How do you know?
Because of the alternate interior angles are congruent.
So remember, you still have alternate interior angles, so you'd still know that, and you would still know this angle measure is 50. Can we figure out those angle measures? Are they both 50?
Would one of them be 30? Like EDC? Would that be 30?
Okay, so what kind of shape would it have to be in order for that to be 30? It's not going to be 30 if this is not a rectangle. We know it's not because a rectangle because these are not 90, right? In a rectangle, those will be base angles, and because that's an isosceles triangle. In a generic parallelogram, that won't be true. So I actually have not given you enough to find the rest of the angle measures. Remember, diagonals are not angle bisectors in general in parallelograms. So unless this was a rhombus, you can't say that that's going to be an angle bisector. We know that it's not a rhombus because this is not bisecting that pair of angles. Okay, so what if I told you this was like, I don't know, 20 degrees? Blair, what would this angle measure be then?
80.
Yeah. And then you could finish it up, right? Then you could say, all right, there's 80, this is 80, this is 20, and you can work your way around the triangles to figure out the angles in the middle then. Okay, but in a generic parallelogram, you don't have very many properties. You basically have alternate interior angles, you have consecutive angles that are supplementary, and you'll have congruent triangles. So you'll still have this one congruent to that one, and this one congruent to that one, but it's not going to be as kind of nice as rectangles are. Okay, rectangles have isosceles triangles. That makes it a bit better. All right, and then one last problem. Ooh, we're almost out of time. With a kite, ugh. With a kite, which diagonal is the line of symmetry? Lily, which diagonal is the line of symmetry?
RY.
So when you start a kite problem, the first thing you should do is focus in on the line of symmetry. And then because it's the line of symmetry, that makes these two the same and it makes these two the same, but not all four of them are the same. What else do we know about the diagonals in a kite? Kendall, what else do we know about the diagonals in a kite?
They form 4 right angles in the center.
They're perpendicular. So when you're doing a kite problem, the first thing you should do is go, okay, I know that they're perpendicular. I know that it's an angle bisector here and here, but those angles are never congruent. Like the big angles are never congruent. And then those angles are always congruent. So before you start even writing numbers in, you got to think through the properties of the different shapes. Okay. All right, I will get the answer key written for the review and I'll post that. But again, I want to remind you that you now have 2 quizzes to study. You have actually like the reviews for the quizzes to study. You're going to have the test review to study. You've got Quizlets to study. Some of you really need to do a lot better on this test than you've done on the quizzes.